Yeah, yeah.
Okay, you can see, right?
Yes, sir.
So yesterday we have seen about the fixed wing operations and aerodynamics. So fixed wing is more or less like a aeroplane only or airplane. Okay, we have seen it wings and it has a similar control parameters for controlling the movement of the aircraft, and then the power is given by the engine. Either it could be internal combustion engine, or it could be what we call as a BLDC motor powered by the battery. Okay, so the advantage of fixed wing is that they are always in a category, not really category. I would say it is a class of large or medium or large class. They will be like, so they will be more or less more than 25 kg of weight. So they are mostly used for surveillance, reconnaissance missions, or mostly they are used by defense, or there is some bigger survey is to be performed. Then only the fixed wings will be used. Whereas now we are going to talk about is the rotorcraft operations, which will be primarily for smaller projects. So first we'll see the overview of a multi-rotor. What is the basic drone view, types of multi-rotor drones, quadcopter anatomy and terminology, and then electronics, inner electronics of a drone, and what are the applications. This is little bit a lengthy topic, and this is the most important part of our training because we are going to get trained on the multi-rotor or rotorcraft drones. So we need to spend more time on this and understand the concept components of this particular category.
Right.
So first of all, what is a drone? Drone is an aerial, ground, or underwater vehicle without a human pilot on board. Okay. This is what is the standard definition as of now, because when initially drones were developed, nobody thought that we'll have a bigger drones also where people will be within the vehicle and they can fly the drone also. As of now, with respect to the drone concept, it is always a vehicle without a human pilot on board. Okay. It is also known as unmanned air vehicle or remotely piloted vehicle. So it can be UAV, RPV. Okay. The entire system. Okay. The entire system means the drone, the remote control, or the ground control station. All that things is there. Then we call it as either unmanned aircraft system or it is remotely piloted aircraft system. RPAS. The entire system is when we are supposed to see not only the drone which the vehicle which is flying in the air or either ground or underwater is not, but the other components also, the remote control, the ground control system, everything comes under UAS or RPAS as a terminology.
Right.
So RPAS again here, see when we this is what more clarification. So remote piloted aircraft plus GCS, the ground control station, is actually your RPAS. Okay, so how does drone works? It may be remotely controlled by a human operator. That means a pilot who is having a remote control in his hand and he is trying to fly. Either through the remote. Currently, earlier remotes were not having LCD or there were no option to fly autonomously. But nowadays, latest remotes which has the LCD and all the things where we can plan and we can schedule the missions. The remotes are capable of flying the drones autonomously also. Whereas earlier there was a ground control station, almost like a suitcase, where it has a LCD panel, multiple LCD panels and controls into it, and people can fly. You can plan your mission and accordingly fly the drone autonomously with the help of the onboard computer or what we called as the flight controllers. Okay, so there were two ways: one is manually flying and one is autonomously flying. Okay, so we have different multi-rotor drones. The rotorcraft with more than two rotors. Okay, so it starts with tricopter. I mean, two rotors also. There are drones with the two rotors also. Three rotors, it is tricopter. Four rotors, it is called quadcopter. Then six hexacopter, and eight is octocopter. Okay. Sometimes you will see a quadcopter having two motors up and down, and that is also called as a octocopter also.
Right.
Quadcopter are most popular and widely used variant. So you see quadcopter is primarily used in multiple locations and applications. Hexacopter is primarily used in the heavier loads where it has to pick up the tanks in agriculture segment or supply chains or supply or delivery kind of things. Then only use more. So basically, having more propellers or motor will give you the more weightage of picking up the higher capacity of the weight to ratio. Then only we'll use. Whereas for smaller applications, like let's say we have to just pick up a small camera or thermal sensors or maybe a lidar and all those things, quadcopter is more or less sufficient to do those kind of activities. If it is going beyond, let's say 8 kg or 10 kg, then probably we'll go for a hexacopter kind of drone. Whereas within the 8 to 10 kg of capacity, I think quadcopter is more than enough for you to do your activities
Got
on
it.
that. Okay. So, what is the pros and cons? Pros of a multi-rotor drone is vertical takeoff and landing, hovering capability, which is most, and operation from a very confined space. Okay, because they are like quadcopter. If you say it doesn't take much small, but like you must have seen FPVs. FPVs are very small, very in a small area you can actually FPV we fly in a such a way that we fly in a very small tight spaces also. Okay, so operation from a confined spaces can be carried out using multi-rotor drones. But what is the limitations of our multi-drones? Is limited endurance compared to the fixed wing. We talked about this in the fixed wing scenario also, like because of they are battery powered and the batteries do not have much of the power to generate or give power to the drones. It could be either 10 minutes, 15 minutes, 20 minutes, max to max 30 minutes what we can get it. Okay, the more battery we try to add it, it will become more heavier. Okay, so there is also where as you try to add more battery, you are going to lose the with respect to the weight also, and the less chance of recovery in case of motor failure. Like in case the motor, like for example, in fixed wing, if you have some problem, you can still glide that aeroplane. Okay, you can glide it and bring it to the
Right.
some location to land it. But whereas in a motor failure in a multi-rotor drone, there is very less chance of recovery. There are some drones which are having a parachute mechanism attached to it, so that it can trigger the parachute and it can land safely. There are some drones which are like made such a way that I mean in quadcopter, if one motor fails, they try to see if there can be done with the three thing, but still there is no stability into it, and we do not know how it will behave in that scenario and how the flight
Right.
control will able to fly the drone with the three motors or two motors and things, because they are not designed for that particular thing. Okay. So the chance of recovery is very less in a multi-rotor in case of motor failure. Then it also has a limited speed compared to the fixed wing. We have seen this, and cannot perform high altitude, long endurance operations. That means it cannot go beyond its capacity of what it can fly, because it cannot go beyond, like let's say 400 feet or let's say 1000 feet in that case, because it will not have that thrust to the ratio of
Right.
weight what it can give. So that's why it cannot perform high altitude, long endurance operation, because your battery is not that capable of doing such kind of activities. So these are more or less multi-rotor are used where you have a challenge in takeoff and landing. So where you need to take your drone in a vertical takeoff and landing. Then the best advantage of the multi-rotor drone is hovering capacity. So that at a particular location you can hold a drone and you can take as many as footage you want to take. You want to
Right.
take multiple snapshots, or you have to take a very short videos, and where you can capture as much as data you want with that. So that is the advantage. So mostly the advantage of a multi-rotor drone is the hovering capability, and the first is vertical takeoff and landing, and then operations from the confined space. Okay, for example, I was actually trying to do power line towers inspections. Okay, or like windmills, or telecom towers, or like chimneys, or even in the landmines. Okay, the multi-rotor drones are used in landmines also, like where you have to go inside. Even landmines are like a GPS denied infrastructure. So normally you will have, always have a challenge to communicate or contact with those particular drones. So in a very confined space, very less controls available in those spaces, we will normally fly the multi-rotor drone.
right,
So we talked about single rotor drone. Helicopter is actually a single rotor drone because you have only one rotor which is moving and it is actually taking the aircraft in the air. So there is a tail rotor also available, but that is just to control the reverse direction of the body and it just stabilize the single rotor drone or helicopter. Okay, it has higher efficiency and maneuverability, higher endurance by using gas powered engines, ideal for large scale surveys and agriculture. Earlier, before drones, helicopters were used for surveys and agriculture spraying and all that things. But as
right,
drones has evolved and drones has given that simplicity of flying and easier for doing and all the things. Everywhere you can't have like small farmer cannot bring helicopter for spraying and all that. Whereas drones has that capacity to you can always take it on lease and within the capacity of a farmer you can use them for agriculture spraying or seeding. Whereas the downside of the single rotor drones or helicopter is complexity, operability, cost, vibration, and other dangers of large spinning blades. So this can be only done in a large. This is what it says: large scale surveys or large agriculture, like big farms you have, like hundreds of 200s of acres of land. You want to do the spraying and all that. In that scenario, you can use helicopter and all that. Whereas for a smaller like I had only a 2 acre of land, I cannot bring a helicopter for doing a spraying activity for
right.
2 acre land. And single rotor drone being utilized for crop spraying. I mean, this was the one of the advantage earlier was done, but the limitation is again large scale agriculture farms only we can use. Okay. So this is just an added advantage of like you have multi-rotor and the fixed wing. The combination of which will be fixed wing plus multi-rotor will have a hybrid VTOL. So your takeoff will
Right.
happen like a rotorcraft. Then it will transition from multi-rotor to fixed wing configuration, and remaining operations will be continue in a fixed wing. Whereas while landing, it will again convert itself into a multi-rotor. Now here the advantage is long range, high endurance, hovering capabilities, and operations from a confined space. Not really big confined space, but I mean because of the wing, based on the wing size and all things, we can perform these operations. So advantage is that it is giving you the what do you say the pros of the fixed wing as well as the multi rotors. What is those
Right.
pros? Long range, higher endurance, hovering capability, operations from a confined space. So whatever the best part of both the categories, fixed wing and multi rotor, we have it in a hybrid VTOL or hybrid drones, what we call. So vertical takeoff and landing can happen. It has a high endurance, hovering capability, operations in a confined space, and it can carry a large payload also. That is also one of the advantage of the VTOLs.
So basically, your Harrier is also a VTOL, right?
Correct, correct.
Yeah.
Okay. Let's see some history of it, like how does the drones came into evolve. So in 1849, you must have seen this, somewhere in NGO, Nat Geo documentary or something, where Australians balloons measuring 5.7 meters in diameter, where they were autonomously sent and they had a fuse mechanism where there were bombs attached to it. So over the particular after particular time, like if they have calculated, like if you fly a balloon or you send a balloon in the air, how much time does it takes to reach that particular distance? That's what they have planned, and then there has some fuse mechanism which will actually detach the attached bombs, and it will start raining, those explosives over the civilian areas and all those things. So that's what actually the concept of unmanned balloons loaded with explosives started, and that's where we say this is the first UAV or unmanned aerial vehicle kind of thing. Okay, though the mechanism of
Okay.
was used as a balloon, filled with hydrogen or helium gas, and then it was flown over it. This was also done during World War II. Okay, Japan has
Right.
used similar balloons, and they were sent over the Pacific Ocean, and then it crossed the Pacific Ocean, and then all these areas like California, Las Vegas, the coastal areas were actually. But so far in World War II, none of the I think only one balloon which was actually reached the terrain, and it actually crashed, and I think there were some casualties happened because of that. Apart from that, there was no balloon reached the locations or this thing. They were actually either mistimed or they have gone, or because of the heavy winds in the Pacific oceans, they have been drifted to the different locations, and probably they dropped all their bombs or the devices, explosive devices, in the sea only.
Right.
There is a documentary on YouTube. You can see that it's very interesting, where you will see how this was planned, and the clever mechanism of launching these explosives and the fuse what they have used. Yeah, I mean, it was very indigenous methodology to do this
Right.
by those people in that point in time. Okay, so that's how the evolution 1848. Then Tesla, Nikola Tesla actually demonstrated that you can control the boat using radio waves, and then that was the first use of balloons. And then initially, when the aircraft were evolved by the Wright brothers, post that, during the World War II, the unmanned aircrafts were primarily used for uh, as a guide. It's like a guided missile kind of thing. And then post what we call as the World War, uh, most of the time it started use for surveying or reconnaissance mission by the army and all. Whereas the first
Right.
drone, actual drone, what was developed in 1974 by Abraham Karim. Okay, we'll see that in next
Mm.
slide. So then Israel and American military staff started using or developing lot different types of drones. So initially they were mostly used for defense or monitoring purposes like weather and all those kind of things. It is really started taking up the if you see the real history of the drones by 2000, uh, people in a commercial space, or I would say in a civilian space, people started using drones mostly for the photography and videography kind of thing. So if you see from 2000, 2002 till 2010 or even till 2015, mostly it was used from a photography or a videography perspective. As the ICAO has started taking this seriously, and they started form a committee, and which started uh, doing the research and came up with the rules and regulations with respect to UAV. The country started taking seriously the drone. So if you see the really drone coming into the picture in a commercial or civilian space is basically from 2014 2015 onwards. Okay, so
Okay.
the first consumer drone you can see is basically in 2016 and so on. We have seen it's an enormous growth in the drone industry, and in
Yeah.
India, I would say a post-pandemic, that is 2020-21. Once we have our drone rules come into the picture, initially there were hardly, I mean, 5 to 10 startups which were working on drones. Post drone 2021 rules, till date we have seen almost more than 200 startups which has come up and working on different applications of the drones. I mean, there is enormous development in this industry, like right from developing a drone to the required softwares to the required personals required to fly. Like almost now we have somewhere around 26,000 pilots uh, trained so far as a remote pilots.
These are in India, right? As in like
Yeah,
registered
yeah,
ones.
yeah. So if I tell you, sorry, not 26,000, it's 12,000. So drones which are registered is
Right.
30,000 now. Okay. Sometimes 1 month back it was roughly around 26, 27,000. So now we have 30,000 drones which are registered on the Digital Sky platform, whereas we have now only 12,000 pilots being trained by the various RPTs
Right.
across the pan India. Okay, so uh, I can tell you that we have only one 62 RPTOs which are available in India. Though the number looks still very big, 162, but there are a lot of RPTOs which were initially registered, but as of now they are not functional. So if I can say out of 162, I can say hardly 50-60% of RPTOs are really operational. There are a lot of many earlier RPTOs which were there, they were not able to run their business, or they are not able to run or compete as more and more
Right.
RPTOs are coming into the segment over there. But nevertheless, we are growing at a very good pace with respect to the number of pilots, with respect to the number of drones getting registered, and as government is supporting more and more this industry with respect to the PLI schemes and giving subsidies to farmers, and lot many things are being offered by the government of India, so that uh, the vision what is being put up by Indian government as of now, that by 2030, drone. I mean, India has to be a global hub for the drones. Okay, that is the vision what we are carrying, and that's why Indian government is very extensively supporting and making sure that they extend whatever the best they can do, so that more and more adoption of the drone happens across the industries.
Right.
So the father of the drone, as I said, Dr. Abraham Karim, he was born in Baghdad, later moved to Israel in 1951. He was actually an aeronautical engineer from Israel Institute of Technology. So he built first drone for Israeli Air Force. However, in 1970 he migrated to United States, where he formed a company called Leading Systems, and that was the first enterprise drone was built over there, which is called as Albatross. So this is the same drone which we now call as the Predator drone. Okay, so inventor of a
Okay.
modern day combat drone, that is Predator, which was brought him the title of father of drones. So this is actually the person who actually really created late recent times drones. I could say that. So initially, this drone was mostly used by U.S. defense and Israeli Air Force for their defense activities and all.
It was still Israel who actually did it first before US.
Yeah, yeah, yeah. Okay. So let's see what is the future of the drone. As we say, as the drones are getting more and more evolved, from the big size drones to the miniature size of drones, have been evolved and been developed by various companies across the globe. You can see the drone taxis, or bigger drones for spraying the things, or miniature drones you can see, or there are drones which are with respect to the concept of uh, what we call fanless
Bladeless.
or bladeless. Okay, this is one of the another concept. And flying a drone for supply or delivery of the parcels, and then again some very miniature size of drones which are used for spying and all that kind of activities.
Right.
There are in development. So there is enormous. Like there was also something called as, recently it is taken up very big way, is drones used for advertisement or publicity or media publicity. So that is called something that's called as Swan technology. Okay, you fly almost more than thousands of drones in the sky, and then you display, or you make some
Yeah, yeah, yeah.
images in the
Some kind
sky.
of video kind of thing in the
Yeah,
sky.
you must have seen during the this Ram Mandir inauguration, or even during
Yes, yes.
even during the matches, or even now a lot of people, even in the marriages and all the things, people are using it. Even during the Chinese New Year, you must have seen it. There was a Guinness record which was,
Right.
so they have flown more than 3,000 plus of drones simultaneously, and they were able to create a digital image in the sky. So this is one of the concept from Tesla where they introduce upper and lower propeller layout. So there are two propellers up and down, and then you have a payload in between. So shifting regular side to side. So there is a different people come up with very crazy ideas of building the drones and using it and flying and all that. So we never know how much and what kind of drones would evolve in next 5 to 10 years. As we talk about lot many things of applications with respect to the drones.
Right. Even the Inspire series changes its shape, right? As in, like when
Yeah,
it's landing, it's different, and when it's in the air, the wings get, the blades
yeah,
get a little
that,
up or something.
correct, correct. Your landing gear also gets folded and all.
Yeah, yeah,
A
yeah.
lot of concepts are coming up with different things. So because they want to fly the drone in a very confined space. Okay,
Right.
there's a concept where people are talking about bladeless drones. Okay, there I think today we are talking about the propellers or the probably I see. I mean I envision that if the development happens in the jet engines. See today jet engines are very big in size. Okay,
Yeah, yeah.
but there is some development happens. See, basically, as the propulsion method gets developed, the drones will get up developed more better. Like if you have some
Right.
miniature of a jet engine, I don't think that we may have in next 3 to 5 years jet powered drones also.
Right. Yeah, yeah.
So
Possible.
that could be a game changer kind of thing. So
Truly.
whatever these jetpacks, what you see are actually nothing but they are actually some kind of a drones only, where
Yeah, yeah.
have been flying using jetpacks and all the things.
Right.
Okay. So coming back to our quadcopter, let's see what is the anatomy of the quadcopter. So you see the propeller which is here. Okay, it's a blade. Then it is powered by a motor which is enhanced, which gives the speed to the propeller when it is flying or when it is started. Then we have the electronic speed controller. So there is a AC, what we call it is normally is required to give the proper voltage to the motor so that at a right amount of RPM the motor is rotating and
Right.
then the propellers are moving. So that has been controlled through the AC circuit board. Okay, then you have something called a flight controller, which is the brain of your drone. Okay, then you have something called gimbal, camera gimbal, which actually controls the motion of the or the stability, which brings actually stability to the payload device,
Right.
camera and all the things. Then you have FPV cameras also mounted on the what we call quadcopter, so that if you want to see what drone is seeing, then you can use FPV goggles to view that.
Right.
And then the powerhouse of the drone is the battery pack. Okay, where you have one or two batteries attached to it. Okay. Then there are a lot of other components like there would be a GPS receivers or telemetry receivers. All those things are which are required for communication part. And then when we
No,
talk
but wouldn't so many small things would affect the speed of the drone? And also अभी जैसे कल we learned कि when a drone flies it goes to where it cuts there and then it flies, so इतने सारी चीजों से वो affect नहीं होगा?
I mean you are talking about the current what picture you are seeing. I mean I didn't understand what is your actually the question.
I'm saying कि look, there are so many cameras and then इतने सब कुछ होने की वजह से ये ड्रोन की फ्लाइट स्पीड और ये सब अफेक्ट नहीं होगा?
Yeah, it will affect because this is not an aerodynamic design. Okay, so definitely it will affect its flight. Okay, so if you see having so many components, that's why if you see this drone and if you see the DJI Phantom, okay, whatever you are seeing here, everything is there in Phantom. But you see
Okay.
the design of the Phantom. Phantom is very aerodynamically designed. You will not see all these components outside. Okay,
It
even
Yes.
basically has a structure over it or a body over it.
correct. Canopy, what we call it as a canopy, or the frame
Okay.
is closed frame. It is called closed frame drone method.
Right.
Okay, only what you see is the camera below it. Okay, whereas rest everything is like completely packed or
Enclosed.
closed, enclosed kind of.
अच्छा अच्छा, इसके ऊपर there's like a cover or something, सिर्फ
Ah,
camera is exposed.
only camera small that is also attached to the gimbal, and that is only exposed. Like if you see the other smaller drones like DJI Air 3 or even Avatar and all that. They are so compact. I mean, they try to make it as much as possible aerodynamic. You see the
Okay.
Right.
design and how it's like a fish. If you see the DJI Air or DJI Avatar or DJI Mavic, all these are made with, they try to make it as much as possible aerodynamic. Okay, but still there is some flaw and all these things will be there and it is affecting the flight time. But as of now, whatever the
Right.
best they can think about it, they have designed it. Over the period of time, there might be some very slender, or I would say very sleeker kind of design would come up that will not able to under, like if you have seen, there is a drone similar to like a helicopter, okay, which is used by
Yes, sir.
US US Army, okay, which is almost like a small hummingbird. Okay, so much so aerodynamically it is designed, but it is cost very high. I mean, it goes
Right.
more than what is normal drone you could purchase from a DJI or any other company. So, are we clear with the components of the drones like propellers, motor,
Yeah.
ESC,
Yes, sir.
cameras, FPVs, flight controller? These things we will see practically when we go for a practical session on day 3. Okay, that time we'll be able to see all these
Sure.
components also.
Sure, sir.
Okay, so anatomy of the continue that propeller converts the rotational motion to a thrust. So typically pushers or puller motors. Okay, so when you see two propellers, okay, if you see here, okay, in this image, this propeller, do you see there is a difference between these two propellers? Can you make out? Are you seeing that either these propellers are similar type or they are different types?
Okay, so the one which
Different.
is, yeah, yeah. So the one which is on the left, that is a little bit curved, and the one
Hmm.
which is
So
in
the
front,
propellers, if you see from a design perspective, they are same.
oh,
I'm saying
okay.
their orientation.
Okay, yeah, yeah. They are opposite.
Yes. So if you see, now use your concept of the topic what we learned, basic principles of flight, the leading edge
Right.
and the trailing edge of the propeller.
Trailing edge.
Okay.
Right,
Now
right.
if you see here, this propeller leading edge is here. Okay, you can see my cursor, right? Whereas the
Yes, yes, yes.
trailing edge
Yes.
is here. So this propeller is called clockwise propeller.
Okay.
Okay,
Okay.
whereas if you see this propeller, okay, or this propeller, okay, here you are seeing my this way, right?
Yes.
If you see
Yes.
these two propellers, okay, the opposite ones, okay, this one and this one, their leading edge is this side, whereas trailing edge is this side. So this is
Got it.
actually moving in anti-clockwise direction.
Okay.
Okay.
So if you see here the next image, you can see here. See, these are the two different types of propellers.
Right, right.
You can see this is the leading edge, whereas this is the trailing edge. Whereas for
Got it.
this propeller, this is the leading edge, the and the backside is the trailing edge. Okay, so they
Okay.
are called as like the CCW or CW. CW is clockwise and CCW is counterclockwise. So depending again how you are mounting these propellers, either you are mounting upper side, then it is puller. That means it is raising. Whereas pusher is upside down. When you might have seen some DJI drones where the propeller is below the motor. Okay, in that scenario, it is called as a pusher. Okay,
Okay.
so that is how you are defined. So propeller dynamics can be modeled by the Bernoulli principle and Newton's third law. Okay, so Bernoulli principle is applicable on the design propeller, and as it pushes the motor down, there is a thrust which is created, and the drone is gone into the air. Okay, so that's
Right.
Newton's third law. So that's why we learned in principles, basic principles of the flight, these two theories. One is the Bernoulli principle and the Newton's third law. Okay.
Right.
Now, what is the motor? Motor is used to rotate the propellers. So currently in drones we use brushless DC motors because of their high efficiency and long lasting. Earlier there were DC motors, okay, which were not brushless; they were brushed DC motors. So there was always a friction, and the efficiency was very low. So that most of the time we have to change those brushes, and they get worn out over the period of time as well. Whereas here in
Right.
BLDC motors there is no brush. Okay, because here your armature is fixed. Okay, the armature is fixed, whereas the magnets are rotating around the armature. Okay, so they have reversed the concept of DC motor in the brushless DC motor. Okay, so you are
Okay.
there is no your armature is not moving, the coil is not moving. In the DC motor your coil is moving, whereas in brushless
Right.
DC motor coil is not moving. The change in the voltage in the coil makes the magnet to move. Okay, that's how
Okay.
the brushless decision. So this has brought in lot of efficiency in the motor movements. Okay, so what is the
Where are the magnets in this
side
BLDC?
in the side?
Okay. Okay. On the circumference perimeter.
Yeah, on the circumference, outside part.
Okay. Right. Okay.
So even in the DC motor, magnets are outside. The layout of the both motors are similar, but in DC motor, the armature which rotates, the coil is actually rotating. Okay,
Right.
since the coil is rotating, the coil, how you give a fixed point to the armature, you cannot give, right, because it is rotating. So that's why you
Right.
have to connect brushes. Okay, whereas here
Okay.
your coil which is giving power, it is not moving, so you can give a fixed wire connect to it. Okay,
Right.
whereas the magnet is moving around it. So by changing the voltage in the coils, the magnet, because of the magnetic change
Right.
in the coil, the magnet gets triggered and the magnet moves across the armature. Okay, so key parameters
Got
of
it.
motors are the motor speed, the thrust value, the compatibility with the AC, and the compatibility with the battery. So based on the whatever the specifications given on the motor, we have to use the respective AC and the battery accordingly. We have to match those values so that we have a very good high efficiency to the thrust of these motors. Okay, then we talked about electronic speed controller, which actually used to vary the motor speed with the precision. So it will actually the electronic circuitry which actually controls, as well as it controls the direction of the motor also. Like you can make the same motor to rotate in a clockwise or in a counterclockwise also. Okay, then it also act as a dynamic brake, so it can stop, I mean it can literally control the movement of
Rotor.
motor. Okay, and then it also has the battery eliminating circuit for powering the flight controllers and receivers. So whatever the signals we receive from the flight controller, it is a very precise signal. So that signal is given to the AC, and then AC controls or gives the very precise speed or the voltage required to have a precise speed for that particular motor. Okay, that's the function of the ESC. Then we have the
Right.
brain of the drone, which we called as a flight controller or autopilot. What we call it's the brain of the UAS, helps in flight stabilization, navigation, and builds up redundancy. Most common flight controllers are like AeroDynamics, DJI, N3 or NASA or M-Lite or NASA MV2 customized. There are now latest version of uh, flight controller is Pixhawk. Okay, this is what is 90, I would say 95% of drones uses Pixhawk, or the flight control derived from the Pixhawk. Okay,
Okay.
derived from the Pixhawk flight controller. So this Pixhawk is basically made by the Ardu pilot. Okay, and then over the period, lot of organization or lot of companies which has adopted this standardization of the flight controller, and they have used. So if you see on this Pixhawk, there is an arrow. Okay, this arrow indicates the front direction. Okay,
Okay.
so there is an arrow, or even on the GPS module, you will see an arrow. So normally this arrow or the arrow on the GPS will always coincide. So that is where we call it as a front direction, or that is the front view of the drone. What we call it is. Okay, so whenever you see a drone, if you want to identify which is the front side of the drone, this is how we actually identify the drone. The heading, what we call it.
But it's not there on DJI drones, right? As in, I haven't noticed it.
DJI drone is completely covered and all the things, so they are not
Exactly.
they are not following it. So normally in DJI drone you will see always you will have a battery which is going from the back side. So that is the back view
Okay.
and the front view what one normally will see.
In
And
the
then
front, you obviously have the gimbal.
gimbal and the camera also. And then you can recognize by the color of the strobe lights also. You will always see front strobe lights are made of a green color and the back strobe lights are they are made with the green lights. Sorry,
Right.
red lights. So that's how it. But the best way is to see the flight controller. Okay? If you are able to see the flight controller in any bigger drones, I'm talking about more of the industrial drones. Okay, or the GPS there will be there. So based on or the view of the camera normally, because most of the time the drone will be always fitted with the FPV camera or the first view camera. So if, whenever you see that camera in the front, that is the heading or that's the front view of the drone.
Right.
Okay, so now let's talk about the airframe. The UA airframe consists of housing of enclosing the electronics, motors, boom bars, and the platform. Okay. There are different configurations in the quadcopter. You can have H set, X shape, plus shape, or H hybrid also. In hybrid also, you have a different uh, H shape also. Okay, primarily it is either X shape or it is what we call as a plus shape. Okay, you will see in these two configuration maximum quadcopters. Okay, end of the day, see it is quadcopter. It doesn't matter how the shape is of the frame. It is the four blades which are there mounted on the frames. It has its own advantage and disadvantages of uh, the frame definition of the
Shape.
frame or the blade. So, like if you see Mavic or even the Inspire or even this thing, most of the drones are being in a form of a X shape kind of thing. Okay, whereas there is one.
Inspire is like an H shape, right? H.
I forgot the actual this thing. Let me check.
Okay.
Yeah, Inspire is like a H, correct? That
Yeah.
which changes the orientation of the landing gear as well as
Right.
the frame or the blades positioning. Yes, this is
Yeah. Yeah.
Inspire. Whereas the other like Mavic or Avata, all those things are like X shape kind of drones.
Right.
Okay. Then the powerhouse of the drone is the battery pack, which we normally the right terminology used by the DGCA is power plant of the UAV. Okay, it could be a rechargeable LiPo or lithium-ion widely used batteries. Okay, which is basically high energy density compared to the conventional batteries. These are basically nominated by a discharge rate and the capacity and the voltage. So you can see here what is the discharge rating, at what rating it will get discharged, what is the capacity it can hold. Like normally, when you see the battery, the endurance is always seen with respect to the capacity what it holds the charge.
Right.
5000 mAh, 10,000 mAh. We are using around batteries of like 16,000 mAh, 21,000 mAh, 21 or 22,000 mAh, as well as 25,000 mAh kind of batteries in agricultural drones. Okay, and then most important is the cell count. These higher mAh batteries will always have 6S cells, whereas here it is written 2S cells. Okay, so higher the cells you have, the more voltage you will able to generate by having more number of cells into the battery.
Just out of curiosity, what is S in that 2S?
2S means two cells.
Acha.
Six
Okay.
means six cells. Six cells will be there. So normally, whatever the batteries we are currently using in agriculture drones, they are six cells. Okay, so there will be
Got it.
six cell combination in the battery.
Okay.
So there would be six. I mean, one cell. one cell can be of multiple those small cells. Okay, so
Small AA batteries
small, like you said, think like a double A batteries. So there could be a 10 double A batteries could be made into a
made
single
up of one
one
cell.
cell, right? So
Right.
like that, there would be six cells. Okay, so you will
Got it.
have six cells giving powering it. So every cell will give you a certain voltage, and which will be multiplied by six. You will get that much of voltage to the battery.
Got it.
Okay, then the other part is like the camera gimbal used to mount the payload, help in stabilization. So if you imagine you are putting a payload, okay, putting a camera to the drone, like you are not attaching a gimbal. Can you still take the photographs,
You can
right, at the different angles? But then you have to power your drone.
drone that way.
That way you have to tilt the drone that way and all that thing. So which
Right.
would cause lot of vibration when the images are between. So you need a stabilize. So you need your drone to be very very stable in the air, whereas you can change the orientation of your camera separately, not with
Right.
to the drone. So that's why we have a gimbal, okay, which also helps in stabilization. So whatever there are pads which are attached to the gimbal. So whatever the vibrations you get into the payload, those are not passed on to the camera or thing. Those are getting stabilized, or stabilized when the drone is in air, and then you can control your pan and tilt motions using the gimbal, and you can take as long as you want your angles of your drone. So I mean, this
Right.
was very useful when we were doing our telecom towers and the power line towers, or even the windmill pictures which we were capturing it, because especially in the power line towers, you see the tower shape is like a pyramid. Okay, so
Right.
as you see, the base is very big in size, and you have to really take a long circle around the tower, and as we climb up, the tower becomes sleeker and smaller, but at a slanter angle. Okay, so you need to do lot of combination and movements of your gimbal, as you fly the drones and you capture. So when we were doing surveillance of a power line tower, a particular tower, we would approximately taking around 300 to 500 photographs. Okay, so
Oh my
imagine
God.
how many photographs in all four directions, and then we have to, because
That is per tower.
huh?
That is for one tower.
One tower, one tower,
Okay.
you are capturing almost the high resolution images, photos of almost 300 to 500 photos. Okay, and then we
Right.
also has to take videos also. Okay, so all 360-degree video also we need to capture. So that video roughly was almost of like 500, what we say, not 500, roughly around
50
1,
FPS.
1 GB, 2 GB kind of
Oh,
data used to get generated. So one
right.
tower was like almost 3 to 5 GB of data we used to have in our laptops. So imagine I'm doing in a day 10 towers. See how much amount of data I'm going to generate. Now it is very difficult for a human to analyze those photographs or those videos and all those things. So it was very difficult. I mean, initially people were doing it in a manual mode, but over the period of time, they were not able to do it manually and all those things. It's very, very difficult. So that's where your big data and AI comes into the pictures. Okay. So we developed a
Right.
software with one of the software company, where we were able to train the AI to identify the faults into power line towers, like nut bolt missing, or could be there was a lot of thefts, especially we have seen in Bihar region, in a remote location. A lot of people, they remove the nut bolts, they remove the member bars also, the supporting bars of the tower, and they sell it off.
Right. Right.
Or even the simple thing like there is a nameplate, number plate attached to the towers. So a lot of people remove those nut bolts and remove those number plates. A lot of time birds would make them nest on the towers. A lot of time even monkeys make their monkey used to come and reside on those towers, and all the things. Lot of time we have seen the insulators where the power lines are connected. They over the period of time, because of atmosphere or high voltage and all that, the insulators also get chipped or or break or broken kind of thing or missing kind of thing.
Right.
Especially a lot of challenges where the power line wires are connected. So in that scenario, this gimbal, because earlier, imagine drone is not there. How you will monitor all these things? So the power
Not
line
possible.
company used to monitor using physical. So person used to go near that tower. Of course, he could not climb that tower. So what they used to do is they used to carry DSLR in their hand. They used to carry binoculars in their hand. So they used to do visual inspections. Okay, a lot of people, I mean, those people used to take photographs, but that photograph is from the ground. Okay, that is again at an angle. So see how much advantage you got for inspecting these power line towers using drones. So this is one of the
Right.
biggest application of the drone, in the infrastructure segment. Even in the telecom towers, if you see, the telecom tower is more complex because there are a lot many things which you can't see from the ground, or you cannot
Right.
every time you can send person to climb the telecom tower or power line towers. Okay, even in the windmill inspections also, windmills are so big and high, and they are operational, so it's become very difficult for a person to go and inspect the windmills every now and then. So see the application
Right.
of drones in this segment. That's why we are saying, or even take an example of roads, railways, or dams, bridges, such kind of a very complex structures, or even currently the buildings, the skyscrapers, the big skyscrapers, which requires a lot of inspections and vigilance from the outside area. You know, so drone has come up so much enormous capabilities and easiness of doing these activities. Like in a day, I can almost survey almost 10 towers of power lines, whereas physically we can do only two or three. Because if you see the length of the distance between the two towers, in a kilometer you can have max 3 to 4 towers only. So see the distance is
Right.
also huge when you are doing it physically. But when you are doing with the drones, in a day I can finish almost 10 to 12 towers. Okay, in a day. So that
Much, much
efficiency
faster.
and much data is able to collect. And because of AI and ML, I can analyze that data very faster and then can generate the reports also faster. Earlier, people used to
Right.
go, like they used to go for a weeks. They will cover the multiple towers, then they will come back, then they will process the images, and then they will make the report. So it is a very lengthy process. Whereas because of the drone, this entire process has shorter timelines, giving you better insight of what is happening. So a lot of time, by the time you submit the report, lot of time there is a breakage or short circuit or power outages and all the things are happening, or outages in the telecom towers and all the things. But because of the drone surveillance happening now, you will have less amount of outages, less amount of power cuttages and power cuts and all that things, or even your telecom signals, loss of signal is not happening. All that things is because of the drone use. So camera gimbal is playing a very important role when we are capturing the visual or infrared or lidar or multispectral or hyperspectral kind of data what you need to capture. The gimbal plays a very important role in that scenario. Okay, so that's about the
Right.
payload of the drone. Every drone will definitely be required a landing struts, what we call, or the legs. Okay, that's where on which the drone lands or is grounded. Okay, they come up in a different. I mean, there are different types of like landing gears, what we call, or landing struts, which we call it. Some drones also have a folding mechanism for the. I have seen there are drones which are recently developed with hydraulic uh, landing gears also, which actually takes up the shocks of the while they are landing, so it does not impact the overall frame. It's a small shock up which normally you see in a cycle, or you must have seen it in your house also, used for cabinets, cabinet doors. You must have seen those
Okay, sir.
Right.
hydraulics, similar hydraulics are being used in drones also now. Okay, now how the communication happens in the quadcopter is we have a radio transmitter and receiver. Yesterday I told you about the frequency. So
UHF.
yeah, UHF what we talk about. So normally the control radio control transmits the input given by the pilot to the receiver via 2.4 gigahertz band. Okay, communication link or the C2 link, what we call is preferred frequency for all the devices is 2.4 gigahertz based on the maximum efficiency. Whereas the video, okay, the FPV video what is get transmitted is at 5.8 gigahertz because it provides a noise free and the best quality video signal. So remember, these are the two frequencies on which the communication happens between the drone and the
Right.
controller. Okay, your radio controls are happening on 2.4 gigahertz, whereas your video transmission is happening at 5.8 gigahertz. Okay. Now, if you see the telemetry, it's the air end in connected to the UAV. You will see a lot of telemetry devices are there, which actually captures a lot of information with related to the drones, like your signal, your data, like altitude, distance, speed, wind speed, battery information. All that things has been transmitted through the telemetry devices. Okay, which actually is either displayed on your RC or on the ground control station also. So you will see all this information like altitude, distance, speed, wind, and wind speed, and other temperature also of the drone. Not many things. Telemetry information is available, which is communicated through the telemetry devices. So basically, these are used for mostly in a larger or where we are doing missions, flight plans or longer duration activities we are performing. So this we need to constantly monitor the altitude, the speed, the wind speed, as well as the temperature, the battery. All that information is required when we are doing bigger missions or bigger flying activities. Yeah. You have any question also?
Uh, no, I think probably it might get covered later on.
Okay. Okay. Okay, so this is what we were talking about. How do we indicate the front or the back view
Right.
of the drone? Okay, so normally based on the even seeing the orientation of the propellers. So as of now, I will not show it here in the picture. I want to show it when we actually see the drone physically. Okay, so that is when I will
Okay.
show how to identify the front view. But there are some methods like LEDs, strobe lights, different colored arms, or some reflective material you will have so that you know. And one more is the best is to see the FPV camera or the camera view orientation of the camera will tell you. But the best, the normal agriculture drone or any other drone where GPS module is visible, you should always say every GPS module will always have a direction.
Right. But that will only be inside the canopy, right? For most of the drones.
Uh, See, like DJI is covering entire thing, but other drones, uh, most of the time their GPS is outside or they are putting it in a such a way that it is visible.
Okay.
Like if you see here the frame, okay, in the frame part, the color of the frame, like you will have two whites and two red kind of thing. So depending upon how you are aligned. See, I can put this two white part here also and black this side also. So it's all up to me
Right.
how I'm configured or how I build the drone or how that organization is building the drone. So in their manual, they would have defined how to identify the front part on the back side of the drone. Or there are some logic we can use, like normally your camera will be always in the front, your battery will be always in the back side. All those basic simple orientation things will be always there. You can't
Got it.
always have a camera on the back side and battery on the front.
Right.
There's no
Right.
logic behind that. Okay, so we'll always put in that way. Like you must have seen the DJI drone. There is always a battery slide at the back side.
At the back side.
You can
Right.
slide the drones inside the inside. You can slide the batteries inside the drones. Whereas camera will be always
Right.
either it is FPV camera or the payload camera. It will be always on the front side. So that's it. Or looking at the colors also, like we said, like here it's not a right picture, but mostly if you see the color, the front strobe light will be always a green color, whereas the back strobe lights will be always a red color. So again, those are customizable as per you or as per the OEMs how they want to orient it. So there is, as of now, there is no standardization in these things. Okay, so these
Right.
skills are yet to be what. I mean, DJI will follow something else. Parrot drones will follow something else. The Hotel drone will follow something else. Similarly, the vendors or the OEMs which makes the agriculture drone, like Garuda, will make their own standardization. IoTech will make their
Right.
own. Other drones will make their own. So as of now, there is no standardization come into the strobe lights, or how do you orient, or how do you. So only what we can see, the orientation is in the flight controller or in the GPS module. Okay, so there is always a
Got it.
arrow marking. So that is the right way of identifying the front view of the or the front side of the drone. But in case, as you said, if these things like flight control is not visible or GPS is not
Right.
visible, then there are other ways to identify. And when we are flying it, when we do our pre-checks, during the pre-checks, we'll come to know what is the direction of the drone. Okay.
Okay.
That's
Okay.
why whenever we fly the drone, it is always advisable to do the pre-check when it is in flight, and then you
Right.
photograph the drone. So when you say pitch forward, you should know which direction it is moving. Okay, so that is
Right.
the front. When you say pitch forward, the direction it is moving, that is your front direction. Okay, so that's
Okay.
how you see the front indicator or the heading of the drone. We talked about ADSB, the Automatic Dependent Surveillance Broadcast. Okay, this basically determines its position by via satellite technology and periodically broadcast it, enabling it to be tracked. So this will come into the picture when UTM will come into the picture. Okay, when we
Right.
have software or even the digital sky, the airspace, what we see there, you will able to see all the drones which are in the air. The moment you are flying in the air, your airspace map of the digital sky will also start displaying the drones. You should, then there might be some indicator. I am not sure how they are going to display it, but there might be some indicator as you zoom it into that particular area. You will see the drone flying in that area, and you can click on that drone, and it will show you the features. I mean the parameters of the drone, like UI number, what altitude, what latitude, longitude, what speed it is flying. All those information will be available once this ADSB components is made mandatory for all the drones. Okay. So this is most
Right.
important part from the airspace. So this will come only into the picture when we are flying a drone beyond our visual line of sight. As of now, we are only authorized to fly the drone in visual line of sight. When we
Right.
are flying beyond visual line of sight or flying within the city, more than 2 kilometers, 5 kilometers kind of range, then this ADSB will be a mandatory requirement for this. Okay, now this real-time ADSB is used now for air traffic control, weather, and flight information services also. Okay, so there is a very big area where how ADSB will be useful, what information will be provided using this device will come in near future. We'll are able to know more about it uh, when we start applying or making mandatory for drone flying. Okay, so far any questions on the topics what we covered?
No, no.
Okay, now if you see, there are lot many other components inside the drones. Okay, so there is something called microcontroller, which is actually the brain in the flight. So when we talk about this flight controller over here, okay, it is not one single chip inside. There are multiple boards or multiple chips inside, performing various things into it. So there will be a microcontroller which is actually the CPU part, or which actually is the brain which processes all the information what it receives. There could be a lot of other sensors would be also there, which will be sending the information to the microcontroller. There would be signals going from the microcontroller to the motors through the ACs. based on the inputs from the sensors and the user inputs. Accordingly, things will be managed and controlled. Often connected to the ground station through radio and connected to the pilot through the control link. So that means this microcontroller is been getting signals from the RC as well as from the ground controller. So from both devices, we can give signals to the microcontroller through the control link. Then there is something called like IMU, what we call altitude and heading reference. It tells where the aircraft is moving. I mean, it sense okay in what direction the drone is moving, whether it is performing a yaw function, whether it is performing a roll function, or whether it is performing a pitch function. Depending on, so there is a sensor, altitude and heading reference sensor. That's why we were talking about how do we indicate which is the front view. So there is a device,
Right.
okay, or altitude or heading reference system which tells the microcontroller what function and what application, what way it is moving, okay, where the aircraft is moving, what actually type of action it is performing, whether it is performing a yaw motion, whether it is performing a roll motion, or whether it is performing a pitch motion, okay? Or it could be a throttle motion also, like altitude. Okay, altitude will give you the throttle motion indication, up and down. Okay, so then there are other internal electronics like IMU, which I tell you. Internal measurement unit is an electronic device that measures and reports a body specific force, angular rate, magnetic field surrounding the body. Okay. So what does it engrobs? It engrobs accelerometer. So this will give you the speed. The gyroscope will give the orientation. Compass will give you the heading. Okay, magnetometer will give you the magnetic field around surrounding the body. So these are very important when you are actually flying drone, somewhere telecom towers or the power line towers. They lot of time they also radiate lot of magnetic field around it. So that magnetic field, how much and all things. Lot of time we have seen when we are flying DJI drones, the basic drones like Mavic or air kind of drones. They get affected as we fly closer to the telecom towers and everything, or telecom wires also, or even the power line towers also. So based on these signals, what we capture through the magnetometers, we normally see that we should be away from those towers, at least minimum 5 to 10 meters, and then we should capture. We should not go beyond uh,
Okay.
5 meters or something like that. And this IMU is basically used for autonomous flights. Okay, it also useful when your GPS fails. It allows GPS receiver to work when GPS signal is unavailable. So there are a lot of inputs given by the inertial measurement unit or IMU when GPS signals are not available, or whenever we have a very big signals. That time IMU actually helps the flight controllers to control the drone or move the drones with respect to the IMU. Okay. Whereas the GPS devices, this white color device or a black color device you will see normally, this GPS module is responsible for provision of longitude, latitude, and elevation points. Okay, it helps the drone navigate in BVLS condition. As of now, we are just flying using GPS in VLS condition, but this will come more when we are actually flying the drone under BVLS conditions. Okay, and it helps to capture the specific location to land, or in case of any emergency, if you want to land a particular drone at a particular location, the GPS signal will be very useful when we need. Okay. The GPS module also help in enabling the some safety features like return to home or return to launch, the points what we defined when the drone is flown from the particular location. Let's say, for example, it is at a one particular location. You take off. The moment you take off from a particular location, that location becomes your return to home or return to launch point. Okay. So based on your configuration in the drone when you initiate. So this is the channel. We saw on the remote control there are multiple other
Right.
switches are there. So those switches
Yeah. Yeah.
we can configure on the remote control to enable these features. Like in case I find that I am not able to control the drone, I do not know what to the drone, I can always initiate by just pressing the particular button or setting the switch on the remote controller to return to home. So automatically the drone will on autonomously. It will go into the return to home feature and it will land. Okay. So this is only possible by using GPS signals. So without
Good.
GPS, you will not able to do these kind of safety features into the drone.
Right.
Okay, so any questions? This is very important. So these are these two slides are very important. Microcontroller, altitude and heading reference, IMU, and the global positioning system. Okay, these are the two slides, which is actually the entire uh, sensors and the brain of the drone, which actually controls or brings the drone into a very stable mode when it is in flight. Okay. So far, any questions you have on these two slides?
No, sir.
So you see, normally you will see one single GPS in a drone, but there are some drones which will always have two GPS modules also. The more GPS you will have, the more stability and more signals from the GPS satellites you will get it. So to have a redundancy, to have more stability, you can have one or two GPS modules on the drones. Normally you will see one or two max. If you have two, that means you have a built-in redundancy for that also. Even in IMU, like you have one IMU, if you see DJI Phantom will have two microcontrollers. Everything is redundant into it. That's how by having multiple things, they are having more stability into the drone. They have two IMUs into the DJI Phantom devices. Okay? So that's how they are able to make it more stable. So it is getting two
Right.
signals. Okay, two devices giving two signals. So that's how they it will always correlate and try to find like my if it is getting similar type of inputs, then it knows that drone is in a very stable or very right accurate. If there is a mismatch into the value, so there will be some algorithm will be built to correct it in a much better way and all that things. It will always consult the GPS signal, it will consult the IMU signal. So there is a huge complexity is built into the computation when it is receiving the signals from these sensors. Okay, we talked about the power module. So you see there will be a power module. It could be either in a form of a small what we call a wire and a chip, or there would be a very big power distribution board, what we call. Okay, so you see there would be a power module which will have a connector on one side, which is supposed to be connected to the battery, and then there would be another connector which is supposed to be connected to the AC or to the PDB, that is power distribution board. And then you will have a small chip which actually monitors the voltages from the battery, okay, and gives inputs to the flight controller, which is actually displayed on your RC or on your GCS device. Okay, so it's basically a voltage regulator which converts the input into the specific amount of inputs to the flight controller. Whereas power distribution board is nothing but it is a like one single controller, one single like you will normally you see quadcopter, there will be four motors. The four motors needs to be connected or given power. So you will have a power distribution board which will have the power from the battery and then it will distribute on the four motors on the drone. So you will have something a square shape power distribution board or hexagonal shape also is available for six uh, motors to be connected on the drones. It can also power different other things like power distribution board also powers up the other things like it could be a camera, it could be LED light or any other devices like the power pump, the motor pump for the agriculture drones. All that things are being powered using the PDB board, power distribution.
Right.
Okay, so with that we complete the anatomy of the drones. Okay, so right from the structure to the propellers, to the motors, to the ACs, the flight controller, the airframe, the battery pack, the camera gimbal. Even the camera gimbal power is given through the power distribution board. The landing stress or the frame on which the drone lands, then the radio transmitter and receiver, the telemetry devices, the indicators, the front indicators, the strobe lights or the LEDs, then the safety feature of ADSB, okay, the microcontrollers, altitude and heading reference systems, inertial measurement unit or what we call it as IMU, or your global positioning system module or GPS module, and the power module and the power distribution mode. These all are the components of your drones, of your rotorcraft. Okay. Now, what are the applications of the drones in the various sectors or quadcopter? It could be used in agriculture for crop and health monitoring, soil health assessment, include resource utilization with respect to the agricultural segment. For forest and wildlife, it will be like wildlife conservation, managing human wildlife conflict, or for forest protection. So, a lot of time, until as the physical person goes or monitors things what is happening, you will only you will come to know what's happening in the forest. And forest is not a small area. Okay, it's in kilometers,
Acres.
not acres, kilometers. Forest is in
Right.
kilometers. Okay, it could be 1,000 kilometers like that. Like big, very big, huge area of
Right.
forest there. So it is not practically possible for forest officials or the rangers, what we call them. Okay, it is not possible for ranger to go every corner of the forest. So drone has immensely helped the forest as well as the wildlife area to become. Think about Africa. Forget about our forest or anything. Think about the Africa like a region. It's like a continent, so big area. Where you
Yeah.
have to monitor the lions, the bisons, or the elephants, or different types of animal life, which needs to be monitored. It becomes very difficult for a human. I mean, I was think about how much people we would require to be employed to monitor such kind of area. So drone has helped immensely in the forest, in the wildlife also, not only from the land or uh, the environment perspective, but even the wildlife conservation perspective also. We can monitor their movements of the wildlife and all the things, and get real time data without actually impacting or affecting the wildlife or the forest. Similarly, urban development like city survey or improved urban planning, project monitoring or project quality assessment. These are also immensely help. Like all earlier, these were all done physically by a person. By when person is involved, there is always a chance of
Of
delays,
error.
especially, okay, or not doing things properly and all the things. Here you can do lot of surveys, faster surveys can happen, faster inputs can be received, and right inputs you could capture. Like a lot of time you do physically activities, physically filling the assessment or doing things. Here, when you are having a drone, you have a data. You will be capturing it in a form of some information. Either it could be photographs or some inputs, thermal, lidar, or hyperspectral, multispectral. What not kind of sensors you
Right.
cover in the picture, and you will have a data. And the frequency of capturing of data is also very high, because that will, like, you can monitor the progress of your, let's say, in a civil project, like you're building a building. Okay, every month you can fly a drone and take a stock of what is happening, how much
Right.
progress we have made it. Similarly, in healthcare segment also, during epidemic or even during the pandemic, we have seen how much enormously it has helped in delivering the food supply, delivering the medical supplies, or even helping the people, or even during the pandemic, crowd monitoring, or making sure the people are staying in house and not going here and there. So cleanliness, hygienic, healthcare delivery, all the things are helped. So in US also you would have seen there is a company called Zipline which actually delivers the blood and the medical supplies in African regions or even the remote areas in US also. Which has helped to reduce the casualties because of lack of availability of blood or the medical supplies and all the things. Even in
Right.
traffic management or in the crowd management part also, uh, drones are being used. Even in the homeland security, like for defense, we have seen it. Real-time surveillance, security planning, especially across the border, like drugs and narcotics, what happens, the transfer and all the things would happen. So that is also controlled using the drones. Okay. And in even disaster management, disaster scenarios like flood is there, storm is there, or fire is there, wildfires are happening also. So those can be also monitored, and even the search and rescue also happens. Or in case of any kind of disaster, delivery of essential goods, we have seen using the larger drones happening using the drones. We talked about
Right.
the mining area also. Like mining is also very hazardous. So monitoring the mines and all the things and all the things becoming difficult. So drones has come up into a very unique and autonomous and indigenous way you can manage mines. Managing the encroachment, contract monitoring, and all the things that are happening in the mines. Remotely, you can monitor the mine operations and all that. Of course, there was initially layout, but a lot of places you can't put everywhere the CCTV cameras in the mines and all that things. So it
Right.
so when you have a drone and everything, you can always fly the drone and take a stock what's happening, what is required, or what is happening at that particular location.
Right. Right.
So these are some of the business ideas for the UAE industries like aerial photography and videography. We have seen commercial inspection services, survey and mapping services, or logistics also. We have seen drones are being extensively used, especially like Australia or America. Amazon has already started using it. Like medical supplies, urban transportation, relief operations. Or if you see in survey and mapping services, a lot of companies require 3D digital elevations, fencing data, survey construction sites for urban planning and development. Or even in commercial inspection service, like as I said, bridges, cell phone or TV towers,
Right.
power plant towers. Even aircrafts are now monitored using drones. Okay? The structure is being monitored using the drones. Or the railway lines, wind turbines, oil and gas pipelines. We had done a project for Reliance in Jamnagar where they wanted to monitor their gas pipelines coming out of the refinery to certain area.
Right.
Those also, or even solar panels. Like right now, we have seen a lot of solar farms, not panels, but solar farms have been set up in different
Right.
areas, Gujarat, Maharashtra, Uttar Pradesh, and those monitoring the huge solar farms is very difficult for a human to do it. So using
Right.
thermal cameras, we can monitor these solar panels for their efficiency and functionality of the solar panels. So there are enormous. I mean, these are just a very small. I would say this is just the tip of an iceberg. What we are seeing the applications of the drones.
Yeah.
I will give a very classic example. If you think about 1980, when computers, the home computers were introduced to humans, people thought
Right.
how much computer will be useful for a man. People didn't thought about application of the computers. But if you see today, the computers are touched every life of the humans now, right? You can't think about anything without a computer now, right? If you think mobile is
Right.
also a computer
It's
only,
a computer,
handheld
tablet,
computer,
everything.
tablet, and all. These are all computers only. So think from that perspective. So today the drones are at the same stage what was the computers at the 1980s, I would say.
Right.
So down the line, 5 years, 10 years, 15 years, 20 years, we never know. Drone will touch every point of our life. We
Yes.
never know what applications will be used for the drones.
Yeah.
Okay, some more business ideas. So residential home inspections, checking the roof, chimneys, slide breaks, other structures, external damage. Like this, I was talking about from the buildings also, or heritage sites also. Like
The
VTC.
drone can be even used for rescue operations, right?
Yeah, so that's where we talked about the disaster management.
Yeah.
Okay, so you can always have then repairs. As you see more and more drones coming into the picture, it's not only that we need pilots, but we also need repair technicians. So drone
Right.
parts and repairs also required. So open a shop for maintenance and repair of drone. So like you purchase a DJI drone, but if sometime you crash it or something, you do not have a service center or something like for those drones. So you are stuck up. But there are some people who had come up and they have set up their own service center or service shop to repair these type of drones also. Then I was talking about drone aerobatic shows like drone racing or some kind of competitions like lot of like IIT Kanpur or IIT Kharagpur or even IIT Mumbai. They regularly organize this kind of competitions also, and even Indian government has started
Had
promoting.
recently introduced a drone which flew up to like 230 kilometers per hour and all.
Yeah, yeah. So that's the race or the speed what we talk, and even
Yeah.
drone soccer. I don't know whether you have heard about this or not. There was a drone soccer competition was held last year also in New Delhi. Okay. Or even this aerial advertisement like flying the banners for businesses, and but you have to make sure that you are flying with specific
Yeah.
restrictions and not flying them in the airspace restriction areas and all that. Okay.
Right.
Then the other side of the drone, like as you're flying drone, you're not just flying it for flying purposes. You are capturing data and all the things. So this segment also like lot of like I capture every day almost 12 power line towers. So I give you an example of one tower, 500 photographs and 1 or 2 GB of video data. So 12 towers is how much data you think. So we need to analyze that data, see each every photograph and find out the anomalies into those
Right.
images. So data analytics is one of the important part where analyzing and processing various forms of data, projecting trends and patterns using the present data. Like you want to design a aerial show using the drone. So you need to program that drone. So you need to configure, you need to fly the drone as per your requirement, as per your the image or whatever the requirement from the customer, you get it. So that all the trends, projecting trends and patterns using the present data. So you need to fly and see how drone performs when you give a particular signal. So those are all automated flight plans is fed and based on the data what you actually plan the flight plans. Okay, again, then the engineering consultancy like drone identification, procurement, operation solutions, obtaining UI numbers and all that being DPC-022 compliant. So a lot of OEMs basically have this kind of consultancy services. You have to make sure your drones are having the annual maintenance contract, the insurance, all that things will come into pictures. Servicing of your drones. Your drones are being serviced on timely service, or they are being checked for any structural damage or any malfunctioning, or so that battery cycles, like especially the battery cycles are there, or your propeller or motorcycles, motor regulation cycle.
Right.
Those are inputs are available in the flight controller module. There is a chip which actually stores all these logs. You know how much it has been flown, how much is being consumed, how much landing. Everything is being stored into the logs of the flight controller. Okay, so those are being managed by these engineering consultancy teams and all. Then as you fly the drone for different activities, and the SaaS based firms are there. So a lot of time you must have heard that drone as a service is coming into the picture now, where small
Yeah.
farmers are not able to afford to purchase the drone, but they can use the drone as a service for their farms and all that things. Okay. So again, we talk about the insurance part also. So a lot of insurance companies have now startup this segment also where they are offering the insurance to the for the drone purpose. Initially, like last one and a half year, there was only one company which was offering UAE insurance. Okay, right now there are more than 10 companies which are offering insurance for their drones. Okay, so it depends upon cover liability, damage, claims to third parties, hull structure. So that's what I said. Whenever we are actually getting the UAE insurance, read the policy document and ask the insurance company what is covered and what is not covered.
Right.
Don't ask just what is covered, but ask what is not covered. So what is not covered, automatically you will come to know if something is missing. You can always tell them, do you have to incur this kind of thing. Like I asked what was covered in my flight, so they said that you have been covered only for a daytime. But since I have to fly in a night time also, I have to ask them to include that also to my drone. Though I don't require it as such, but to be on a safer side, I have asked them to cover it in the night time because I'm not going to fly entire night my drones. But since my drone was flying after the sunset, so their daytime is when the sun is in the sky and when sun is not in the sky. Where sunrise to sunset is their daytime. After the sunset till the sunrise is their night time. That's how they define it. Okay, so they will come to know if I've flown and had some accident or some incident related to drone, and if I try to claim using the flight logs, they will come to know when actually the drone was flown or when it was
Right.
flown last time and all that. Automatically, I will lose my insurance capability and all that. Okay, so this is just future of the drone. So when we talk about connecting society, it is Internet of drones is the future. So it could be in agriculture, it could be in medical supply, monitoring the smart power grids. Okay, this is what we have already introduced last year. That is drone ports. Okay, so there is something called vertiports which will get set up across the country. So there is already on the highways, on the roads, okay, bigger highways, especially Indian government is planning to set up the ports, vertiports, so that your drone can land over there at a certain amount of time. Okay, so those are like drones where you can change the batteries, you can change or land a drone in case of any kind of emergency. Let's say you are flying a drone from Mumbai to Pune or Mumbai to Surat. In that scenario, in case in between you have some kind of you are monitoring your drone on UTM channel or UTM what do you say, software, and you thought that there is some problem and you need to land your drone. You need in between some ports, right? So those are your drone ports,
Right.
or party ports, what we talk about. Then drones in the traffic surveillance or the real-time notification, or even drones can be like first responder kind of thing uh, in various segments, or even railway monitoring or traffic surveillance, real-time notification, or even in a connected homes also. A lot of time you can provide the information, or even for private and hobby purposes also you are flying the drone in future. Climate monitoring can happen, or even monitoring the cars, driverless cars or driverless buses in future can also happen through the drones. So that's what I was talking about down the line,
Right.
5 years, 10 years, 20 years. This is what the vision we see of the drones, or drones will be get adopted into the society or in the community. So that was the last slide of the rotorcraft operations and aerodynamics. So any questions on the rotorcraft operations or aerodynamics?
The components bit, will we do a recap when we actually get on site?
Yes, yes. I told you, when we do the what we call the simulator session on day three.
Yeah, yeah.
So that time we will actually see the components of the drone as well as we see the real drone also that one.
Okay.
I have a box over there where I have kept all the components of the drones, right from
Great.
motors to propellers. So you can physically see the motor, you can physically see the battery, you can physically see the board, you can physically see the frame.
Nice.
Okay,
Nice.
this is just for demo purposes. We have bought a separate parts because we can't bring the industrial grade drone parts because they are very expensive and keeping
Right. Right.
seeing it, it's no use of it. Okay, like one motor costs almost 20,000 rupees. So I cannot bring
Oh,
that.
very
I
expensive.
can
Yeah.
bring smaller motors which are used similar type of motors, which will give an idea and example for you like or frame. Frame itself cost, if you talk about the frame itself cost 55,000 rupees. EFT frames
Right.
cost minimum it costs from 55,000 and above. Okay? Because they are made of carbon fiber and all. So we have smaller frames which are less cost, which I have used it for demo purposes or for seeing for students to see what it is, how does it look. So with that, we end the rotorcraft operations and aerodynamics. We have only one small presentation now, that is for the hybrid operations and dynamics. Though we have covered not many things with regard to that, but there are some slides which are required to be displayed. So I'll quickly do that and then we'll end today's session over
Sure.
here. Another 10 minutes I will take.
Yeah. Yeah.
Sure, sir.
Here we just have 10, 11 slides only. So, we talked about uh, fixed wing operations and aerodynamics yesterday, and today we saw seen the rotorcraft operations and aerodynamics. So, combination of these two are hybrid operations and aerodynamics.
Right.
You will have the functionality of airplane as well as the rotorcraft drone into these hybrid drones or what we call it as a VTOL. Okay. So what is the principle of aerodynamics we have used in an airplane? Same will be applicable to the hybrid part also. Okay. And then we'll see types of hybrid drones and parts and what are the applications of hybrid UAV. So here the principles of aerodynamics is same as aeroplane. You will have four forces acting on a drone, that is lift, weight, thrust, and drag. Whereas the airflow changes and the pressure distribution over the airfoil, because here we are using in hybrid we are using the structure like a aeroplane, as well as we are having a structure similar to the rotorcraft also.
Right.
So on aeroplane will, when it is in aeroplane mode, okay, that time all these things will come into the picture: the lift, the weight, thrust, and the drag. Okay.
Aerofoil and aerofoil is same, right?
Uh, aerofoil or aerofoil means is the cross section of the wing.
Yeah. Yeah. That
Yes.
and in the previous slide, I think there's written airfoil over airfoil. So that's also same, right?
Yeah. Airfoil is the same distribution
Yeah.
over the pressure distribution over the airfoil. This is
Right.
also airfoil, okay, or
Got
aerofoil.
it.
Same thing.
Right.
Okay, we have seen this during our basic principles of the
Yes.
flight.
Yes.
This is the cross section of the wing. So you see a leading edge and the trailing edge. Okay, a straight line is drawn, that is called as a chord line, whereas there is a curvature line which is drawn between the leading edge and the trailing edge based on the shape of the airfoil, that is called as a camber line. Okay, so see the difference between two lines. Huh? Don't get confused. But most important is the chord line. Okay,
Right.
for you to understand. Okay, camber line is just to differentiate the upper part and the lower part of the aerofoil. Okay, so leading edge is the part of the aerofoil. Trailing edge is the part of the airplane which hits the air particles last. Leading edge is the air particle hits the first. Chord line is the straight line joining the leading edge and the trailing edge of the airfoil. Chord is the distance between the leading edge and the trailing edge. Means this is the distance. Chord. Okay, the distance. what is the chord we
right,
normally capture. Okay, this is basically when you go into the detail about it. Now, when we differentiate, how do you differentiate? Lower surface is the surface of the airfoil between the leading edge and trailing edge on the lower surface. Upper surface is nothing but the surface of the airfoil between the leading on the upper side. Mean camber line is the line joining the leading edge and trailing edge equidistant from the upper and the lower surface. That's why if you see this image, chord line, if you see this distance from the lower surface to upper line, there is a difference between them. But there is an equidistance when we
right,
talk about the camber line, because camber line make the equal distance from the upper surface and the lower surface. That's how you identify the camber line and the chord line. Chord line is straight line from the leading edge to the trailing edge, whereas camber line is the line connecting leading edge and trailing edge, but the distance between the upper side and the lower side between the line is same. Okay. Maximum camber line is the maximum distance within mean camber from the chord line. Okay, whereas the maximum thickness is the maximum distance from the lower surface to the upper surface. See, these are not very important with respect to the when we are flying the drone. These are more from the design perspective, or when we are designing a drone, hybrid drone kind of thing. Then those only comes into the picture when we want to understand what is the camber line and how much maximum camber or maximum thickness is required for drone to sorry, the airplane to fly in the efficient way in the air. Most important is the chord line, leading edge, trailing edge. These are the three parameters which you need to keep in your mind when you are
right,
talking about the drone or the airplane. Okay. We talked about these force acting on the drones. Similarly, when force are acting on the hybrid drone, when it functioning like a aeroplane, the lift is the force that holds the drone in the air. The wing creates most of the lift used by the airplane. The weight is nothing but it's the force caused by the gravity or the the weight of the drone. Thrust is nothing but the forward force, the force that moves aircraft in the direction of the motion. It is created with the help of the propeller, okay, jet engine or a rocket. Okay, like jet engine is like an example of a rocket only. Okay, air is pulled in and then pushed out in opposite direction. And one example is the household fan. Okay, so you will see this thrust is being created by the front propeller, or sometimes the propeller is at the back side also. Okay, so that is we call it the opposite direction thrust is here. Whereas
right,
drag is nothing but the body. The body itself will give a drag in the air. Okay, the drag is the force that acts opposite to the direction of the motion. Okay, it tends to slow an object. Drag is caused by the friction and the difference in the air pressure. Example you can do, like when you are driving a car and you move, take your hand outside the window, you see the your hand goes back, right? That's the drag. What is been engulfed on your hand. That's the feeling what it puts on your hand. That's because your hand is causing the drag on the air because of the motion. The hand is going to go forward, but the air is pushing it back because of the surface feature or the friction what it is getting. Okay, so that's how the drag comes into it. So drag, any device, you will never have a zero drag. There will be always a drag. So sometimes somebody asks, can I have a zero drag on the aircraft? So there you should always say you cannot have a zero drag on an aircraft or any device or any object which is moving in the air or in the atmosphere.
right,
Okay. So again, the same talks about upper line stream or lower line stream. Upper line will go at a high velocity, which will cause the low pressure, whereas the below stream will go at a high pressure, it will and go at a low velocity. Since the lower side it has to cover the shorter distance, whereas the upper side has to cover the longer distance. The difference between the pressure, that is the low pressure and the high pressure, will cause the wing to move in the upward direction. That is what we call as a lift. Okay, so that's how we call it as a Bernoulli function or Bernoulli equation. So higher velocity produces lower pressure on the rope, or lower velocity produces the higher pressure on the bottom. So that's the difference in the pressure produces the lift. Okay. Yesterday also we have seen this in the basic principles of the flight.
Yes, sir.
Okay, so let's see what are the parts of the hybrid drones. So hybrid drone, when we see from an aeroplane perspective, we'll see the fuselage, the wing structure, which is having the ailerons. Then you will see the tail section with the horizontal tail as well as the vertical tail for elevators and the rudder section. And then you will see four propellers attached to the wings in a such a way that it can make a rotorcraft also. So this rotorcraft or the four motors are basically used for takeoff and landing, whereas the fifth motor, which is normally used as a pusher motor, okay, here since it is at the backside, that's why it is called pusher motor. If the motor was here and the propeller was in the front, it could be called as a puller motor. Okay, since it is at the backside, it is called push. It is giving a push from the backside. Okay, whereas if the propeller was in the front or the motor was in the front and it would be then we call it as a puller motor. Okay, then we have a control surface like ailerons, radars, elevators, which actually maneuvers the hybrid drone when it is in a airplane mode kind of. Okay, so we'll see on the next slide how the transition happens when it is flying the drone in the air. Okay, so there are different configuration of the hybrid drone. So when your drone is there, in vertical takeoff, it will happen. It will go in the air and then it will do a transitional maneuver. Okay, so you see here, sometimes some hybrid drones, the same propeller are being used for different functions. So they will change their angles. The motor itself will change the angle. Okay,
Right.
or sometimes the entire body also get tilts. Okay, there is a very famous drone called Wingtra. Okay, if you search on YouTube, I have a picture of it also. I'll show it to you. Where
Okay.
it changes its angle and it goes into the horizontal flight. Okay, it can do a vertical takeoff, then it changes its angle and goes into a horizontal flight. Then it performs its task, and when it is supposed to land, it will again come up into the vertical mode and it will land vertically on the ground. Okay, so that's how the different drones are there. You can change the position of the motor also, whereas in this drone there is no change in the motion of the uh, orientation of the motor is not changed. Each motor, like these four motors, have only function of taking off and landing, whereas this motor has only function of pushing forward the drone. Okay, so there are different motors for different functions. Whereas in this scenario, the same motor is used for upward and downward motions as well as the forward motions. Only the motor position or the angle is getting changed based on the function what is to be performed in different flights. When it is vertical takeoff or vertical landing, the motor is in vertical direction, whereas when it is in a horizontal flight, the motor is in horizontal directions. Okay, so are we clear on this configuration of the drone?
Right. Yeah.
So this is what I was talking about. So there are different types of hybrid drones. Okay, some drones are like this, where you have a separate motors for different functions. Whereas I was talking about this drone where you have a drone where the angle of the motor and propellers are getting changed. Okay, so when it is takeoff, your motor is like this. It changes here. The body itself changes its orientation. Okay, whereas there are some drones where the motor angle changes and performs the different functions, whether it is have to perform a vertical takeoff or landing, or whether it has to perform a horizontal flight. Based on that, the motor angle is changing, which corresponds to the propeller motion. Okay, so you can see here in this picture. Okay, when it is in forward motion, it is having a horizontal flight. When it is in a vertical direction, it is performing its vertical takeoff or landing action.
That's the V-22 copter, right?
Which one? This one?
Yeah.
Probably. I don't know the name as of now.
Aja.
Could be.
Yeah.
Right. This is very. Actually, I am trying to build this type of a drone for myself. Okay, so
Oh, nice.
I'm trying to make it. Uh, I have got the components, but I'm not able. I've not yet got the structure built yet. So
Right.
down the line, 3 months, I plan to build this drone and test it in month of May somewhere
Nice.
for some project I'm trying to build it. one of the companies in Rajasthan is working with me to build VTOL drones. So
Nice.
I'm
Oh,
giving a
nice.
consultancy service to them on designing the drone for them.
Okay. Okay.
So, what are the applications of hybrid VTOLs? They are used in operations where terrain is difficult to land a fixed wing aeroplane, but endurance needed is more than a multi rotor. Like, like areas like Kerala or Assam, where you have a lot many terrain kind of area, and you have to monitor the tea farms and all those things. So, in those areas, hybrid VTOLs comes into the picture. It is used in large area mapping. If you see this Vintra is primarily been used for large area mapping. It's a very very
Okay.
very efficient, stable, and the endurance is very high of this drone. Very simple. It gets folded into a small case also. It doesn't take much.
Okay.
And all that. This length from year to year it is just 4 meters. Okay, it's like the size of a table. I would say not much bigger into that.
Will we get to see this one?
No, we don't. Nobody has it in India.
Acha, okay.
Okay, this is primarily used in European or US. Nobody is using it in India as of now. Okay, it is used to transport heavy payloads over large distance within a heli and all. So that's where the hybrid VTOLs are being used. It is also used in search and rescue because of capability of vertical takeoff and landing, and then having a high endurance. Okay, and especially cargo delivery also is happening using hybrid VTOLs. So you will see a bigger hybrid VTOLs, especially in the cargo delivery or the supply chain kind of things in near future. You'll see it. Okay, there
Right.
is one of the company which is actually uh, testing their hybrid VTOL between Vasai to Bhiwandi to transfer the packages. Okay, so there is one of the company is actually testing the drones for the cargo delivery using hybrid VTOL design. Okay. So with that, we complete our three topics related to fixed wing operations, rotorcraft operations, and hybrid operations and their aerodynamics.
Nice.
Right? We were
right, sir.
actually supposed to complete today weather and meteorology, but we lost 1 hour today. But nevertheless, probably I might have to take one more additional day. Uh, Either it could be, I mean, you can tell me if you are comfortable to do a session on Saturday, so
Yeah,
that
Yeah,
yeah.
yeah, sir.
so Saturday also we will have a session in the evening. Okay. And I just got to know today in the evening about the resort availability. Earlier, yesterday I told you it is 11, 12, and 13. But I think they have something on 11th over there. So they have requested me to schedule the flying on 12th, 13th, and 14th. So I hope you are comfortable on those 3 days. Because
Yeah, sir.
Wednesday, Thursday, and Friday,
Yeah, sir, not
Right.
an issue.
no issue, right? And I think there would be two more students would also join us at that point in time on flying. Okay,
Okay.
Okay, sir.
so we'll have a good interaction with the people. Uh, I think they are from some uh, ship. Ship. I think they design ships and they do some work on the ship and all. So they want to learn about the drones used in the naval part.
Okay, they are from
Okay,
Merchant
sir.
Navy, is it?
I have just interacted them with one day. I will come to know about them tomorrow. Okay, tomorrow.
Okay.
So they are actually going to join us for flying the drones on
Nice.
12, 13, and 14. So as of now, our flying schedule will be on 12, 13, and 14. Okay.
Okay.
So
All right, sir.
I will share you the details officially on the WhatsApp about the schedule, and then accordingly you need to plan your travel as well as I will help you to do the stay and stay booking at the resort and all. So I
Great,
Okay,
will
sir.
share
great.
you all the details on the WhatsApp. So that's apart from the logistics part. Uh, do you have any questions related to the topics what we have covered today?
Nothing
No,
yet.
sir. All clear.
I hope everything is clear and go through the summary sheets. Okay, at least spend 10 minutes uh, once in a day. I mean, early in the morning time or the evening time. Spend time on the summary sheet. Whatever I have spoken to you already, everything is summarized into the summary sheets. So as I complete the topic, you just go through the summary sheet. And summary sheets is not
Sure.
very big. It is just 11 pages.
Yeah,
Every
yeah,
topic
yeah.
one page. If you have seen the summary sheet, every topic what I teach you or every presentation I do is one page.
Right.
Summarized in one page. Okay, all the
Yes, sir.
important points are covered into the summary sheet. So it will help you to prepare your for your theory test also. Okay,
Yep,
so go
yep.
through that, and if you have any questions, you can ask me tomorrow, or we can conclude today's session over here. And tomorrow
Yeah,
we'll start sharp at 7. Okay, so let's see you tomorrow,
sure.
and good night to
Good
you.
night.
Both of you.
Good
All right, sir.
night.
Good night.
Good night.
Thank
Thank you.
you.
Thank
Bye
you.
bye.
Bye.
Bye, sir.